In this video, I'll show you how to configure Amundsen as a Feast user interface. Feast is an open source project to develop feature store system, a place to store data required for machine learning models training and predictions. It has very granular architecture, but it lacks user interface that could be used by data scientists to collaborate on features. Amundsen is also an open source project to provide visibility of the data available in a huge variety of database technologies. It has great front-end, good search and collaboration capabilities, so it fits ideally in the feature store scenario. Let's start by installing Feast. First, let's clone the Feast Git repository and check out 0.8.2 version. Then, as one of the prerequisites, a secret with PostgreSQL password must be created. Finally, we can install the Feast using Helm charts, skipping Kafka, Grafana, Prometheus and Redis installation, as they are not needed for the demo. While Feast starts, let's install Amundsen. First step is to clone the main Amundsen repository. I'm going to use Helm charts here as well, and first the dependencies must be downloaded. Then Amundsen stack can be installed right away. I'm adding a few options to limit the memory usage for the internal Elasticsearch component, so the entire setup can fit in 4 GB of RAM. At this time, Feast should be already up and running. For the demo purposes, I'm going to use provided example notebook. Let's forward the port for Jupyter container that got installed a minute ago. In Jupyter interface, first look for a minimal directory. The provided notebook contains a set of commands to generate data, creating 2 feature tables in Feast, one with driver trips and the second with driver statistics. Use menu cell run all to run the notebook, then move to the top of the page. As you can see in the introduction cell, the presented functionalities is registration of the mentioned feature tables. The notebook should execute quite fast. If you look closely at the content of cell marked as in 10, you will see that this is the place when the Feast internal database gets updated with the feature table's definitions. Just after registration, notebooks start ingesting fake data into Feast offline store, but the registration itself is enough to be able to retrieve the features descriptions from Feast core component. Now, it's finally a time to create and run data builder job that will scan Feast for available feature tables and transfer them one by one to Amundsen internal databases. As you can see, I'm building a tiny Docker image that contains Python interpreter, downloads current code of Amundsen's data builder from GitHub, and installs the package using with extra Feast client. The build is quite fast because I have a cached layers already. On fresh environment it will take about a minute to complete. Then I need to get a few endpoints information. The services that will be used to load the data are Elasticsearch, used internally for search capabilities, Feast code as a source of truth, and Neo4j as backend of Amundsen's metadata service. Finally, it is a time to run the container. I'm asking my local Kubernetes cluster to run the image I've just built in the default namespace. Then, when I'm in the image, the sample provided script is used to run the metadata transfer. It takes 3 parameters: Feast core endpoint, Neo4j endpoint and Elasticsearch URL to move the metadata between these databases using Amundsen's extractors and publishers. First it gets all project registered in Feast, we have only the default one, then it transfers the feature tables descriptions to the graph database. Next, it gets the data form Neo4j and pushes them in searchable format to S. I'm expecting to see some warnings in the end, as this is very first run of the loader. It looks the data loaded properly, so let's verify is using Amundsen front-end service. We need to forward port 5000 to get access to the service. The main component of Amundsen frontend is a search box, like in Google. Let's try to look for features related to drivers. There are 2 returned results. It shouldn't surprise us, as example Feast notebook created registered these 2. The interface allows to browse the information stored in Feast as a list of columns containing entities and features, but you can spot on the left also information on the sources of the feature table. It also allows collaboration. You can edit the feature's description, and the information is persisted in as the graph database. Other users of the frontend can see it. You can also describe the feature table itself and add tags. Please be aware that the descriptions are searchable only after next loader run, when the Elasticsearch index is refreshed. As you can see, setting up the synchronization between Feast and Amundsen is pretty straightforward and provides a missing piece in the Feast world, a user interface to discover and collaborate on features. Thanks for waiting.